Greetings, you've landed at the VUC, IP Communications and VoIP Community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com. And how cool is all that? You know what? This is VUC 523 for some time in 2015, probably some 9th of January. Yeah, that's it, the 9th of January. And as soon as I find my camera, I think it's this. Yeah, there we go. So we have a visitor that's revisiting. The last time Michael Iedema was here, it was in a fog hangover from Jägermeister days at AmuCon in 2009. But want everybody to welcome back Michael, because he's got a lot of interesting history to share with us. Michael, glad you could make it. And he's muted.
No, I had to find the little button,
right.
And now I've figured it out. Yeah, I had to look myself when the last time I was on. I had significantly more hair and facial hair features. So, yeah, it's been a while. I don't know. Should I? Is there? I don't know how things are structured. I don't know if I should just go through a little spiel about the book, or.
Well, here's the thing, Michael. We run a very, very tight ship here. Things are extremely structured, as I explained to you in numerous very detailed emails. We absolutely follow a specific thing. The talking points that you submitted will be covered. Now, let's just do a little bit of quick history on you, though. All kidding aside, and then we are here to talk about the book. Oh, you know what? Before I forget, because I'm getting old, go to openbts.org/book. Download this book now while it's still free, right, Michael?
Yep, it's free for the next I think it's maybe week, exclusively on the site, and then after that week it will remain free on the site, but you can also purchase it on normal bookstore places like Amazon and whatnot. And then that those sales actually go back to OpenBTS. So it's a good thing if you really like the book and it helped you out. Then buy a copy if you want one for yourself or your Kindle.
Right. But first, run and download it free, and then evaluate it, and if you like it, yeah. And let's contribute to OpenBTS by purchasing it. I often do that. I have the book in front of me in electronic form, and it's actually pretty neat because I just read your intro. I haven't actually looked at it, but the book itself. But in the intro, you mention your goals and so on, and we'll get to that in just a second. But before we do, as I said, you and I met in about 2009 at AmuCon, which was a great conference, and I really wish Stefan would be doing more of those. That was in Germany. You landed in Germany. You were a student there. Let's hear a little bit about a quick one on Escosia PBX, how that even started, and how you zoom forward to today and what you're doing at Range Networks. Can we do that in like 3 sentences?
Sure. maybe 5, but Escosia PBX was a research project, actually. I had done some research for Auerswald. It's a German telecommunications company, and trying to make their stuff easier to use, and self-discovery on the networks and things like that. And so after that project ended, I wanted to see if we could build something like that in open source components and put it out there. And as far as an open source project goes, that didn't have very much community, because surprise, surprise, if you're building a consumer-oriented open source thing, you're targeting consumers, and they don't write patches. So it's better if you're writing an open source physics library or something like that. I think that gets a lot more participation. So anyway, I did that until 2010, and then was hired away actually by Ubiquity Networks to do the same thing for them, and did that for about a year and a half, and then got on with Range after that project was done. So I've been with Range since the end of 2012, and just been messing around with OpenBTS since then. And it was quite the learning curve.
I can imagine, because you were coming from VoIP, as you said in the book, and this is radio, right? And this is interesting to us. James is a ham radio operator. I was for years, and I don't know, several other people who are listening are or were. And this SDR, software-defined radios, is a really interesting topic. By the way, Tim Panton is with us. He's muted right now, and he's sitting quietly in his chair, being very nice. But he's also had plenty of exposure to OpenBTS. As a matter of fact, he was in on the early days, if I'm not mistaken. You can nod, Tim, if you want. But I think he was, well, fairly early days. This SDR, Michael, if you don't mind, because I'm interested in that myself, these are modules that you can purchase, and they connect via USB, according to what my very quick reading of the book. Is that it? Tell me a little about that.
Sure, SDRs are pretty cool stuff. If you could have another absolute SDR expert come on here and talk about how they're going to change the world and completely, really change the world in the next 10 years. They used to be super expensive things you could only get from the military. 15, 20 years ago, they were only for military applications, and what they let you do is, instead of writing your radio logic, your decoding and encoding logic in hardware, or building it into an FPGA once, it actually lets you build that logic in user space. So you can write a C++ application that, I don't know, opens a garage door, and you hook it up to an SDR that's capable of addressing those frequencies for your garage door, and you can open the garage door. What's cool is, if you want to use the same SDR to open a garage door and listen to FM radio at the same time, you can do that. You need two applications running, sampling the entire spectrum from the radio, and you can do those two things concurrently. So two totally different logical radios on one physical piece of hardware. So they're really cool stuff. I don't know. They just keep getting cheaper, so I hope they really do tank out in the next couple years. Really get down to everybody.
James is asking about the specific models in IRC, but before you get into that, I was curious about there's a huge range, apparently, frequency ranges, goes up into the gigahertz from some low megahertz, relatively shortwave, right?
You can get ones. I don't have specific ranges in mind. I should. But some of them are, mid, like 400 megahertz to 3.2 gigahertz. So you can't. It doesn't mean you can grab that entire bandwidth at the same time. But depending on how many mega samples that the radio is rated for, that's what dictates how much of that range you can actually listen to or interact with at the same time. So some of them have, some SDRs have lower bandwidth. Some of them have lower ranges that they're capable of addressing. It depends. It depends on the design. Some of them can also address a very wide range, but extremely poorly. So depending on your application, like UMTS, we're finding that UMTS, the UMTS version of OpenBTS is quite a bit more sensitive to radio quality. So you really have to have some higher end equipment to do it right.
And again, James has another question, which is the current configuration covers 850, 900, 1800, 1900 megahertz bands, which, as we all know.
Yeah, which, that sounds like, wow, crazy. That's a huge range of frequency, but it's really not for these things. To go from 850 to roughly double is no big deal. To sample that entire range, you can't do that, but you can sample, 2 or 3 carrier signals at the same time. Then it depends more on your host PC, how much horsepower you're actually throwing at this thing. You're interpreting and producing analog signals with a digital program, so the math is always not exactly the most light task.
I imagine there is a lot of math. I'm trying to follow the book here a little bit too, and the first chapter is on hardware. James did ask about any specific modules you could name. Obviously, he should get the book.
The book is written with a couple of radios in mind. What Range Networks used to do is count on selling hardware. That's how we made our money in the past. So we designed the custom SDR that works very well with GSM networks, and we're moving away from that. So the other radio that's defined in the book, or that's outlined in the book, is the Edis Research N210, and that's a Ethernet connected SDR. So it has a separate power supply and has a little Ethernet cable off to your host PC, and that one does. I think that one does do 2100 megahertz as listed in the chat, saying specifically that it doesn't do 2100, but I believe that radio does do it. So they also have USB connected radios. Edis Research is our recommended supplier of radios. They have the B200, B210, N200, N210, and then they have even higher end models there that really cost thousands of dollars. So it's good stuff, and a lot of people in the community use it and have used it for years. So it's pretty trusted too. There are patches for the new Blade RF, and that has already been integrated in a fork of OpenBTS called EidemaBTS. Their transceiver supports Blade RF radios. So to move that logic back into the OpenBTS project is not going to be that hard. It just hasn't been done yet. So you need to get that support added back in.
I think one question also would be, obviously, who's interested in this book, but who's interested in OpenBTS in the first place? And who would want to go to openbts.org?
We find so many different people that want it. It's one of the main problems of probably Range's marketing people is like who specifically though. We have research labs that research wireless security. There are application developers that want to see how their applications or how the underlying operating system of the handset is using the cellular network.
Members of the Chaos Computer Club in Germany. I quite like it.
What?
The CCC quite like OpenBTS as well.
They like it, but they also use the Osmocom stacks. And that,
yeah, and the Fairwave thing, the motorcycle engine thing.
Yeah, and that's all.
The problem with that is you can't wander around with one of those.
Approach to what we do.
Yeah, you can't wander around with one of those in your pocket though. That's a drawback.
That is, the number one problem of all the technology is it's still highly regulated. All the frequency is highly regulated. So the people that are interested in it are either already having permission to use that frequency, or like a lab or an incumbent carrier, somebody that already has frequency, or people who have the exact opposite situation where they don't have any cellular access and they want to set up a network. And so regulation really needs to change to get this shift in how networks are deployed. You need to be able to free up a few carrier pairs in different geographic regions to get this to work. And the EU is kind of on the front of this compared to the US for sure. They have opened up, or the EU didn't do it, but individual countries within the EU region anyway. Sweden opened up a couple of guard band signals that you can use for any use up to 100 milliwatts. The UK also has 2 or 3 pairs.
We can run up to 300 milliwatts.
300 milliwatt. Okay. Yeah, different laws in different countries. That's why I'm not real sure right now which ones have which. The Netherlands as well have guard bands that you can use for public installs, but it's all very low wattage. Mexico just passed a law not too long ago, maybe within the last 6 weeks even. They are regulating certain frequencies explicitly for community use. So that will never be, deployed across the entire country. It will be an independent operator in, village A sets up a tower on frequency X, and another independent operator sets up the exact same frequency, but it's in a different village, so it doesn't matter. So that's pretty forward thinking to get that kind of regulation passed. That's letter of the law. You can't use this stuff, so use it without permission. So really make sure you do.
Even the 1800 DECT band here in UK, it is licensed, but it is possible to get sub-licenses to use it. I don't know whether you know exactly what's going on here. There's a bit of a drive at the moment to make a lot more license-free spectrum available, and in particular, there's a lot of excitement about putting LTE on the 5 gig band and on the new 3.6 gig band as well. So all of a sudden, we're going to see a huge explosion in the number of devices that actually support these bands. And I don't know whether, Michael, you were at Mobile World Congress last year. Normally, if you want to see what's going to be in handsets in about 18 to 24 months' time, you just go and have a look at what they're demonstrating on the Qualcomm stand, and that will give you a good idea. And one of the big things last year was LTE operating in 5 and 3.6 gig. And so we're expecting to see the launch of the first handsets with 5 and 3.6 gig LTE capability at Mobile World Congress this year, hopefully.
Am I right in thinking, though, that LTE, all of the protocol specs are heavily patented, so something like OpenBTS would struggle to implement LTE? Or is that old story, not true anymore?
Well, we are working on LTE. We have LTE working at a beacon level in the lab, but we're more, this year trying to finish up GSM. Really package it up, make it even more scalable, and handle a lot more concurrent RFCONs on the same radio, and allow a lot more capacity on the same tower, and also finish up UMTS. So we have voice and text. Right now, UMTS support is only data. So, and there are countries that only have 3G, which is I don't know, maybe counterintuitive, but there are just countries where 3G is the only thing that's interesting, and there's some countries where LTE is the only thing that's interesting, and there's some countries where there are no towers at all, so anything at all would be interesting. So to try and match up what everyone wants and what everyone needs is pretty tough. As far as LTE goes, as far as I know, I don't think there are any nothing on the radio interface that's patented that we can't use. Maybe there is in authentication algorithms, encryption schemes, things like that. But
there are constraints, but they're not patents. The issue with getting LTE working is that you've got to get it working right the way up the protocol stack, and it is considerably different to 2G and 3G. And whilst it's relatively straightforward, I suppose, these days to get the radio access layer working, it's getting the other bits and pieces like the authentication working. This is one of the areas in which Diana, who's not on today, has been doing some really interesting things, but kind of doing her own thing and cheating a little bit by using 2G authentication on an LTE system. But no doubt she'll pop back at some time and tell us all about that.
Range's approach has always been a little, like I said, compared to like Osmocom. They want to play nicely with existing infrastructure and still want to integrate there, and we do too. But first, we want to go to SIP. We want to make it as thin as possible. The jump from here you have a GSM handset or a UMTS handset, and on the other side you have a voice over IP switch or a SIP infrastructure of some sort. And we want to be able to get those handsets to talk to that infrastructure transparently. Neither side has a clue that the opposite is not a SIP desk phone or a GSM core network. So then after that, we would be building bridges that convert from SIP to whatever core infrastructure is in place. And for example, roaming, Range Networks has roaming working in the lab. Also has a product that's, okay, I'm not entitled to say when, but it is productized and ready to go. Whenever that's going to be sold, I don't know, but that's our approach. We get everything to voice over IP first, and then what do you need to build? Is your infrastructure already voice over IP and compatible? Is it already SIP and RTP? Great. If it's not, what do we have to now convert back to get into your existing 2G, 3G, 4G core network? So it's an extra step, but I think it's maybe academically much cleaner than trying to wire everything together at every possible juncture.
Anyway, Michael, it's probably a good thing to actually talk about pricing of these kind of modules now, and talk about where the pricing is going, how it's trending in a downwards direction. So how much are your current generation of modules if you want to buy one for the lab?
I believe the development kit for the lab is, I think it's $2,300, and that comes with, I have one here. I have one here that's pulled open like Frankenstein. It's kind of destroyed, but just to show you, because I test with everything outside the box, but it's just a little, it's not even a pizza box. It's not 19 inches. It's a Range Networks radio. It does not have an amplifier in it because it's only designed to be used, locally on a desk at about 10-20 meter radius for testing. It has I believe an i5 in it. I'm not sure. I have an older version right now, and it has an Atom board in it. And the Atom board is enough for 7 concurrent calls on GSM. So, but since we're shipping UMTS and things like that on the software level, the main processor has to be much quicker now to be able to support that on the radio, to be able to process the radio. So those are 2,300 are full-size base stations, 50-watt base stations. Those are $20,000 plus. That's a real investment for a real purpose. That's a 19-inch rack. It's a 2U 19-inch rack with a linear power amp inside, and an i7. I think it's a 4-core i7. So that's those are two totally different things, price-wise, but component-wise, the major thing that costs money is improving your radio chain, improving the amplifier, adding an amplifier actually, and then adding a duplexer to clean up your incoming and outgoing signals. So clean up your uplink and downlink signals, separate them from each other. So those are the expensive pieces. A radio by itself, you can get a radio for $400 or $500. You can get away with just the radio as a USB, like I have hanging off of my computer, how I work every day. It's just this. It's just a very tiny USB module. It has 12-volt power and USB-D. So those things are, less than $1,000, and you can start developing just with that if you're fine using a virtual machine on your desktop.
Yeah. Yeah, it's amazing what you can do with mass production as well. The kind of UMTS and now LTE femtocell modules that are deployed by outfits like Free in France. In fact, Randy has one in his flat. And I don't know whether you're aware, BT are launching very shortly, within the next couple of weeks, 2.6 gig LTE femtocells in every BT home hub. So that's going to be about 4.2 million of them lurking around in UK, which is pretty scary. But they reckon they've got the incremental cost of dropping a 2.6 gig LTE femtocell running, I think it's either 100 or 300 milliwatts, down to about £50, which is amazing. Amazing what you can do with scale, isn't it?
Which is, I think,
we're still waiting for that to happen on the SDR, generic SDRs. Still waiting for that to happen.
Yeah.
I think that kind of tells you why Range wants to get back into software and out of the radio business. You know, there's just too much competition in that, and you know, it's not the magic in OpenBTS, certainly from my point of view, is the fun of being able to do whatever it is you wanted to do with it, and not be limited to whatever your big carrier BT chooses to do and their pricing plans, and you know, where they choose to put networks and whatever else. So it's the flexibility of it being software that's the joy. Coming back to the book, I haven't actually managed to download it yet, but can you give me a kind of sense of the structure of it? Who's it aimed at, Michael?
Sure. Yeah, by the way, that is definitely why Range is getting out of hardware. It's, you know, it's like telephony cards were 6 years ago. Anyway, the book is it was written because so many people were excited about the technology, but they're not radio people, and so there's a hurdle. There's another hurdle because you actually have to have hardware to try out some software. So it's not like every I don't know, Perl programming book you've ever read. You just open up an editor and go to town. So to even get started on this book, to get started with this technology, you had to kind of have a half a dozen pieces lined up correctly, and then the software would start for the first time. So there are, oh cool, they're showing some figures from the book. But anyway, it goes through all that. It goes through covering which hardware components do you need, where to get them, about how much are they going to cost, what kind of test sims do you need, phones, antennas, how to get your development environment set up, how to download the code, how to compile it, how to install your dependent libraries, how to start and stop services, things like that that people, as soon as you don't know how to execute some upstart command in Linux, you're already off of having fun. So the maximum amount of fun was tried to be achieved here. The next step after you finally get things running is a bunch of tests, a bunch of sanity tests. This stuff is still not self-healing or completely idiot-proof, so you really have to have the tools in place to be able to see if the connection from the radio to the PC is working, and see if the PC sees the radio, and see if the radio can see the handset, and see if the handset can see the radio, and all these different incremental debugging steps. And then how to actually configure the network itself, not to stomp on your neighbors, how to test different RF conditions, how to set up the SMS and authorization server, and asterisk is actually used as the voice switch inside here. So all those things step by step. And then also the challenge was not everyone's going to have $1,000 to just spend on a SDR for fun, unless you're in a lab and that's your magic budget number is $1,000. Enough information had to be in here and background be provided that reading the book just in a vacuum without anything else, without even a computer, like just reading a 120-page book on a flight, would give you a lot of background information and let you know what this is all about and what you could or could not do with it, what it is for, and what it's not capable of doing yet. So try to squeeze all that in, and then there's a whole section on the different APIs that have been implemented. There's a cheat sheet at the end, which I also teach a 3-day class for different customers. And that 3-day class, by the end of it, it's come up many times that I wish I just had a cheat sheet. What are all the different paths to the files that are involved? What are the different ports that are involved? What are the different settings that change those ports? And how can I check if X, Y, or Z is working? So there's a little appendix on that. And none of this stuff is magic, but it's just never been compiled into a single spot before. It's never been 120 page quick reference to get yourself up from scratch and have a couple of successes with your network. So there's definitely room for the ultimate reference type book, but for now, this is I think it's going to be a good help for people.
This is actually a very cool book. I don't have any intention of implementing anything like this, but it's really interesting to look at the generalities of it. And I think you've done a good job of reaching the goal, Michael, where the book has enough context so that you don't have to know everything before you look at it. It's well worth it. And by the way, it's certainly worth the price if you go to openbts.org/book and grab it right now for free. And then if you like it or you want to work with OpenBTS, you can also buy like 20 copies for the lab rats or something. I don't know. That would be my approach. If I had a company and I was using this stuff, you would certainly probably want to buy it. By the way, do people openbts.org, is this something that you can be a part of, or you know what I mean? Is this like a community thing? There are forums, or tell us about that a little.
There's an email list, and as much as people love email lists, people also hate email lists. It's one of those divisive things. But, I would like to add a forum. I would like to add a place where we can track answers to questions that have been asked a half a dozen times and pin them in some place and gather knowledge. Actually add a knowledge base, QA, FAQ, whatever you want to call it, however it's going to be built. But something like that I think needs to happen, because there's a lot of smart people out there. I mean, anytime there's an RF question, it goes over my head, unless it's the basics and troubleshooting and things like that. It's very quickly out of my reach. But there are people on that list that understand it and can help you out with it. There's a lot of people just trying things out, which can always tell you if it does work or not. There's a bunch of radios that I don't have access to, that other people do, and they can easily give you feedback on it. So the email list is right now the way to go. We're also on Twitter. Some people ask questions on Twitter. Most likely your question won't be, graphically explained in 140 characters, but we can probably tell you where to go to actually get a proper answer, or send a link to a chapter or something like that. So yeah, definitely stop by, sign up for the list. It's not a very high volume list, so you can even just kind of lurk and see what goes on there for a month, and maybe it's interesting enough. Some of the discussions that are happening right now on UMTS auth and GPRS have helped us try and track down a few different bugs still hanging out in the code.
How about maybe rather than running your own forum, which is a whole other cost involved, possibility of either Google Plus community or Google, the old style, for example, we started on Google mailing lists, but Google Groups evolved from mailing lists. It turns into a kind of a forum. So it's all on Google, but the good news is it's Google that handles everything, including software updates, and you never have to worry about anything. The bad news is Google's in charge of everything. So that may or may not be, and is everybody signed up to Google is the other obvious thing.
Yeah, that's even if SourceForge added a nice way to embed search, or to pin topics or link things, if they added some features like that, we would stick on SourceForge on their email lists and not worry about it, because we really do like an email list. I like it. It's right in my inbox. I sort through the new questions and I'm done. But that what is the buzzword of the last the entire internet generation of curation. There's no curation, so you kind of are left with this
There is in that.
gigantic field of information from everyone, and there's no categorization. There's no organization.
Yeah, well, I mean, I don't know how many people are involved. A community probably would be good, but I mean, there's a lot of platforms. Google isn't the only one, but obviously there's Facebook too. Somehow I don't see the people that are interested in OpenBTS as big Facebook fans. It doesn't seem like it would be the right match.
No, I've used. I switched Discosia from email lists to the forums, and the only thing I did was add forums. I never said that the email lists were going to go away, and people just started using the forums.
Forums on what? Oh, your own
hosted. What was it called? Simple Machines. Simple Machine Forum. It's you install it on a LAMP server, and that's it. It wasn't too hard to maintain. Just the default template. It was fine. Well, people just started migrating over there.
Yeah, that'll work. Not to change the topic, but just to put in my own experience with it, which is that people, if your audience is already using Gmail, then Google Plus for community would actually be pretty good. You do have to curate and moderate it. But otherwise, if you're running your own, you have the disadvantage of having to host it and running it and curate it. And also, people have to register, obviously, to post. So it's that whole thing. If the people who are interested in this topic don't mind registering, I mean, whenever I buy something that doesn't work, I have to go register on their forum, obviously, to get support. So, there is that.
I'm looking for a newer, there's got to be a new forum software that uses OAuth in some halfway modern, this decade way that lets you log in with Twitter or Facebook or Gmail or whatever. There was one that I looked at when it was on the table of how we should probably fix that forum problem. So I went and looked up a couple different solutions out there, and of course I don't want to host it either, and this is also just a rat hole of complaining. But anyway, I called them for a quote. I won't say the name of the company, but I called them for a quote. This is the size of the community and whatever. We'd like to use your platform because it looks really good. And they said, well, that's no problem. That will be about $140,000 for a year.
Oh, that's nice.
So, you can either pay engineering staff full-time, or you can have, like, a forum on the internet. So we'll find something in between those two things going forward.
Okay. Anyway, any good time to break for some questions, because we've been all over the place here, and that's always my fault, as always. Any questions on IRC? I'm looking. People have been repeating. Thank you, Andy and James, for repeating that they should go to openbts.org/book to download this book. You have 1 week. So if you're listening to this and it's February, forget about it. But seriously, or Tim looks rather pleased, so I guess things are going well.
Yeah, I'm pleased. I'm curious to know whether I'm going to see Michael again in Burning Man at some point in the future. Last time we met, that was very dusty. I think. I don't think we've seen each other since.
I don't think so. That was interesting. Yeah, we were there. It was 2013, right? Yeah, just last year. 2013. Range has a alternate persona of the Papa Legba camp, or it's not an alternate persona of Range Networks. That's not fair. It is people who are enthusiastic about open source networks and cell networks, and some of them happen to have built Range Networks in their real lives. So yeah, we were out in the middle of the desert and set up. What did we get? 4 towers? No, 2 towers. 2 towers, 4 sectors up. And that year there were 68,000 people on the playa with, was it 40,000 handsets? There was an estimate I remember hearing. I don't know. Tim did really cool analytics of the traffic that we saw, and so there's some nice graphs. And the weirdest thing that I learned out of that whole experience is, well, hydrate. But the other one was that Verizon, their little fake SIM that they have in their stupid phones, pretends that it comes from the Netherlands. So when that SIM says, oh, I don't have a Verizon signal out here, I need to connect to a GSM network, it identifies itself as a Dutch SIM. So
yeah, I looked at those figures and I said, why are there so many Dutchmen out here? I mean, it just seemed implausible. And then David said, no, this is why. It's it's this craziness of Verizon. So yeah, there was a perfectly legitimate reason. So you were talking about the enhancements in OpenBTS to handle more RFINs on a radio channel. Does that mean that we need fewer towers to supply the same number of users for kind of registration traffic, or what? I'm somewhat ignorant on the radio end of stuff.
yes, it would mean exactly that. We spent a lot of time. We built a wall O Android phones, and it had, I think we had 40 handsets up there, just cheapy little Android phones, and wrote an application for the Android phones that is controlled over Wi-Fi, and you can tell it to do things: place a call, next call it comes in, answer after X seconds, send an SMS, things like that, or deregister, re-register. And we did a bunch of stress testing, and out of that we learned that the multi-ARFCN support could be improved in quite a few different ways. So there's new DSP code in there that lets multiple ARFCNs run on the same tower cleaner, or more cleaner. Wow, too much time over in Europe. Anyway, in a much better way. There's another, so that was one enhancement. The other enhancement was the control channel count and allocation. We took the control channels, and there was a rewrite of some layer 2 stuff that lets us expand the amount of control channels available by about 16x. So whereas you would only have 1 or 2 threads servicing authentication requests or SMS, now you have 16 or 32 individual workers on that traffic, and without taking up additional resources. We changed our beacon type to support more traffic. What else did we do? But a big part of it was also just making layer 2 work better. Version 4 was a complete rewrite of layer 3 that included the state machine. That's what we were testing at Burning Man that year, was the version 4 rewrite. So it was a completely new state machine for layer 3. And version 5 now has a lot of rewritten layer 2 code and scheduling code and thread management code for layer 2. So yeah, it should really support a lot more traffic with the same amount of radio bandwidth.
Cool. We should try and get it out there and play.
Oh, here we go. Tim of the desert again.
Michael, chapter 4, single to multi-node. You might want to explain a little bit about the difference between handover and roaming and all of that. Can we get into that a little bit? Because you mentioned several towers.
Oh, sure. Yeah. This is why it's called a cellular network, because it's made out of cells. So if you have one on your desk and all the components are running on that, IP or that machine, then you have a single cell, and it's a network in a box type setup. So that chapter covers the theory and the actual practical conversion of one single tower into 2 or n multiple towers, and how they then talk to some central authority. So it's, of course, different how OpenBTS does it than how traditional networks do it. And it goes and covers the different identity settings that you have to set correctly. There's 2 different categories of identity settings on a cellular network, and some of them identify the logical network that's being broadcast, and other ones identify the physical network, the physical tower that you're connected to. So you have to get those things set up correctly. There you go. There's the perfect graphic. Central services is what we refer to as these 3 little three little services that handle SIP registers, SIP message, and SIP invites, and it's asterisk, SMQ, and SIP-auth-serve. SMQ and SIP-auth-serve are little components that are part of the OpenBTS project. SIP-auth-serve handles a modified version of SIP register that lets you use GSM specific, or actually alternate authentication hashes. So instead of using MD5 like SIP does, it lets you use comp128 v1, v2, v3, not v2, but whatever. You can replace and put in your own external program there, and it will run the hashing requests through that program, which is needed to be able to support authentication in the handsets. And this is how to set up your proxies. You have to tell OpenBTS, where do I send voice, where do I send text messages, where do I send registrations. And then this graphic actually shows how to organize your network so that your neighbors aren't interfering with each other. And this is a color map. You assign a pair of an ARFGAN and a base station color code, and then that pair represents some color in your network, and you make sure that those colors don't touch each other. That's about the biggest task you have, is to make sure they don't overlap, because if they overlap, the identities being exchanged will confuse the handset, and if they overlap on the frequency, then they'll actually just interfere with each other, and it won't work. So it's if a network planning person looked at this, they would laugh, because there are entire businesses and industries built on network planning and RF coverage, propagation modeling, and things like that. The book isn't hand-wavy about it. It's very direct. It says, you will probably have to pay somebody to do this right if you're actually going to set up a big network. If you're going to set up 40-meter masts all over the countryside, you're probably going to have to pay someone who knows what they're doing. But getting multi-node working in the lab is always, or not in the lab, when I do this for classes, you always have to, you put 4 base stations in the room and have people walk around the room like a cakewalk and see if their handset will associate to each tower. So if you're not on a phone call, if you're not in an active session, that's called mobility. When the cell phone is in your pocket, for example, and you're riding your bike through town or whatever, the phone will decide on its own which tower it should connect to. It makes the decision, but and that's called mobility. But if you're on a call, driving in your car with a headset, of course, very safely, then the network is the one that decides. It's the one that tells the handset, you're seeing this tower with a much better reception level, and this one's starting to fade away, so you should hand over to this new tower now. And then the handset has to.
You know, I don't know if this is a good question. Let me get myself back in here. I'm not sure if this is related, close enough related, but this just happened today. I was asked about something to do with our 4G, our LTE service here, and in order to enable certain things, you have to make a phone call first to an order data service, and you'll see where this is going. It's actually kind of close to what you were saying. So my carrier, you have to make a phone call for it to get everything to know about your phone before you can do data with LTE. My question that's actually related to our topic is, once the tower and someone's phone are talking, what kind of information is exchanged? There must be actually a considerable amount of stuff, not just authentication or whatever, but capabilities of the device, whatever. What is that all about?
There's a whole bunch of stuff you can ask the phone, or that the network can ask the phone. The network has that type of information. It's in the beacon, so it's a broadcast channel. Anybody can decode it and listen to it. It's not protected in any way, and that lets you know, can I make an emergency call on this network, for example? Is this something I can connect to and make an emergency call on? So that stuff's right in the beacon. But when the handset connects to the network, and you can force that by making a call. Then you'll make sure that if it hasn't done this location update, that the location update, is performed and processed. During that location update request, LUR, location update request, you can ask many things about the phone. You can ask it which encryption standards it supports. You can ask it if it supports radio resource location protocol, if it supports a GPS chip, if it knows where it is, if it can tell you where it is. And power capabilities, I think, are also included. What's the maximum transmit power capability of the handset, minimum transmit power.
Will it tell you where it is without your permission? I mean, your permission is obviously given implicitly by the fact that you have a phone on with a radio. So can this tower kind of know where you are?
Yeah, you can ask it. RRLP was designed for exactly that. It's most common use is emergency calls. When you make a call in, during that exchange or shortly after the call has been set up, then there's a way to query and say, where is this phone exactly? Like, give me your latest fix. And the phone.
This fix is based on what, though? Not the GPS in the phone.
GPS, yeah, GPS fix.
Wow.
Yeah, certain types of handset will do exactly that.
By the way, speaking of emergency calls, stop tapping, James. Speaking of emergency,
that's a 15-year-old boy. Dungeon window.
You can make, as we all know, you can make emergency calls. Well, if you don't have a SIM in your phone, it says emergency calls only. So that's a little bit to do with the process you just mentioned, which is the tower. You got no SIM, so you actually have no juice. You got no money, no subscription to anything. You're maybe in a foreign country even, but the radio has arranged with the tower, however you want to look at it, that you are. I assume, by the way, this is by law, that you are able to make an emergency call, right?
Well, it's actually not connected to the tower at that point. It's if the SIM's not in there, it's on, the radio's on, it's ready to go.
Oh, that's just a prompt saying.
It's just letting you know the only type of call you're going to be able to make right now is an emergency call.
So then, if you wanted to make one after looking at that, it might say, "But as it happens, there's no power."
Yeah. Okay. And maybe it does scan and let you know that there's towers in the area, and maybe it'll hide that message if there are. I mean, if you're in the middle of nowhere, if you're on a cruise ship or something, like, okay, I can't actually make an emergency call. There's nothing out here. But emergency calls in GSM are a completely different operation than just a mobile originated call. So when you dial 911 or 112 on your handset, it doesn't actually call the number that you dialed. It tells the handset, oh, that's an emergency number. The handset firmware knows that's an emergency number. I need to make an emergency call now. And then its setup message with the tower is, I want to make an emergency call now. And that's why this is so fun to make sure people know when you're testing with this. If you make an emergency call in your lab, which has access to other towers, and your tower in your lab is set to not handle emergency calls, you will end up talking to a real person, because your handset will say, oh, that's cool, the lab environment does not support emergency calls, but somebody's trying to make an emergency call, let me find another tower. It'll quickly find one, connect, and all of a sudden you're talking to a 911 operator. And they'll say, hello, what's your emergency? And it's quite a jarring thing if you're expecting to just be in your own little sandbox in your lab. A friend of a friend told me this once. That
sounds more like you've actually experienced it.
No, it honestly was somebody else's story. But it is really jarring when that happens. You're expecting your little, your Allison prompt to say, "Oh, you have an emergency," or play back Weasels or something, and there's a real operator that picks up the phone because the GSM handset did its job. It connected you to emergency services.
Yeah,
and
it's
Matthew,
exactly the same if you're running a dual mode VoIP handset. You try and make an emergency call on the VoIP side. It'll default to send an emergency call out over the GSM side because that's what it's programmed to do.
Matthew says pretty sure only emergency calls available is typically only shown if you do actually have a BTS in sight on current smartphones at least. Then he says he's putting his smartphone in the microwave to see. But anyway.
That makes sense. Yeah, I mean, it can't say emergency calls only when you're not in any reception at all.
I don't know. It's hard to see, who's tested that, right?
It shouldn't. It would be mean.
I've seen that. However, our data went down. Phone service went down here yesterday, both data and voice, and I did not see the emergency calls only message, so it was connected to nothing for some reason. That's an interesting little anomaly. In other words, since we're well covered here, but our coverage was not working, and I did not see any message about calls. There was no bars, no data. But nothing.
Well, Randy, you can actually be connected to nothing with nothing showing on the front of the handset and still make an emergency call.
That's a good point. I should have tried just to see, and then when just kidding. Anyway,
I've got two terrorists in here.
We've got. We're coming to the point where we should look at anything that we have not covered. Besides,
yeah, I've got another question.
Sure.
Which is, for you, Michael. I mean, at the moment, there's quite a lot of surplus 2G gear coming up on the surplus market. I was talking to a recycler of hardware, and he was sitting on a pile of something like 250 Huawei radios, which had come back from a rural operator in the United States. And these are quite big things. I mean, they're 40-watt transmitters. Have you ever considered doing things with surplus equipment and just using the OpenBTS backend and to operate in as the base station controller for some of this surplus hardware?
We don't do that at all. Well,
I know you don't.
We don't really have a backend so to speak. It's only voice over IP back there. Whatever components we have are only SIP. The project that really does that is OpenBSC. And they've done it for a few years now, and with surplus hardware that's out there. So so a little background. There's a BTS, and multiple BTSs need a BSC, base station controller. In OpenBTS, the BTS and BSC components are the same. They're terminated inside the software itself. So there is not an external BSC or MSC or anything like that upstream. It's all just terminated in software inside OpenBTS. It's a couple of CPP files. So we don't really have that, but those guys do, and they've used that successfully. And I don't know what the range of equipment is that is supported, but that's their goal. Is they take OpenBSC and they point it at an existing BTS, and then they can adopt it into a network. I don't know at what level. On the other side of OpenBSC, how it ties into networks, but yeah, it's pretty cool stuff to be able to reuse some of that hardware out there. It is really expensive stuff being sold for very little money right now.
Yeah, there's a lot of it floating around all of a sudden as the network operators try and switch out their older 2G stuff and replace it with LTE.
I think another good question for this moment would be, Michael, would be if anything is coming up, any meetings, any what do you call these conferences, whatever. You're in Europe, like I am. Anything interesting coming up either here or in the United States?
I have a bit of a empty spell here. I'm working on a couple of just pure engineering things, so there's not a lot of travel planned for the next weeks and weeks. There is one thing that is just an invitation from which I was finally able to actually do, is to go to a conference that's a security conference at my old college. So that's coming up in March, DakotaCon it's called, and it's just a little conference in South Dakota at Dakota State University. So that's pretty cool to be able to go back. I've wanted to go back forever to be able to do the event, and this year it worked out. So that's going to be nice. Going to be more talking probably about SDRs and attack vectors, all of a sudden you have this freely programmable radio, and you could address every typical example, every garage door opener in your entire neighborhood if you wanted to, at the same time with a single radio. So it's more of a security conference. It's not OpenBTS specific.
Okay, there is a last-minute question in IRC from guest 8448, who I met several years ago at a conference. No, he says, or he or she says, do you know about a medium-sized OpenBTS deployment example? Is there any documentation out there? I don't know. We could talk for a second about deployments if there's anything you care to say about that.
Sure. Yeah. There's two different types of deployments that I really like talking about. The one is exactly what is being asked there, medium size, and that's in a region of Canada that's actually technically, politically France. So, but it is in geographic Canada, called St. Pierre, and it's there's a couple other towns around there, and I can't remember the names because I wasn't directly involved in it. But anyway, they have a pure OpenBTS network running over 5 or 6 towers, and each tower has one, or I think half of the towers have more than one sector. So that's a pretty decent deployment for a pure OpenBTS environment. Of course, it's a greenfield deployment, so you can choose choose whatever backend you want and whatever you're comfortable with. So if you're comfortable with an existing billing solution and all that, you can just tie it right in together and go. There's no integration needed at that level. So that's a really cool deployment. We've had people up there different times of the year, and it's been cold every time for them up there. But it does work, and then the operator seems to be pretty happy with it. They're running version 5. Got to jump the capacity up with version 5, like I mentioned before. So that was pretty cool to have a pure OpenBTS network out there. The other deployment is not really a deployment; it's an application, and it goes to kind of show what you can do with OpenBTS that's not serving phone calls. The Icelandic Coast Guard, I think Coast Guard or government and Red Cross, I think it's a Coast Guard though, of Iceland, they started developing a system that uses OpenBTS, and some of the at the time data that was inside of OpenBTS, they wrote patches for it. Now we have an API for it that does this for you, and lets you extract raw radio data out of OpenBTS as JSON messages. Anyway, what they do is they take that raw radio data, and they also initiate a state in OpenBTS where they will let any phone connect to it and start interacting with it, sending it text messages, whatever, anything to keep the radio alive with that phone. They take this base station that they've built with this additional logic, and they mount it on helicopters, and then they fly it around remote regions to try and find lost people. And so it actually has been extremely successful finding hikers, as opposed to sending out 100 or 200 people on foot. They put one helicopter up, one base station on it, start flying figure eights around a given area, and all the triangulation data that comes in, you have data from a GPS vector and also the other vectors from the radio, and that together lets you do the math that lets you they have a tagline on their website. The system itself is called Norris, Norris, Norris.is is their website, and they narrow the search field down from a possible 35 square kilometers or 35 kilometer radius to the size of about a soccer field. So it's pretty cool use of the technology that wasn't in the initial planning, of course, for the software. So who knows what else is out there? That's why we're trying to add APIs so people can start surfacing this raw data that's being passed around in there.
That's very cool. Michael, it's great to see you again, and I hope we'll meet again in person around a glass or two or a bottle or two of Jaeger one of these days, or maybe you're
Yeah, if there's any nice conferences in Europe, it's nice because it's just it's a day trip. So
yeah. Well, actually, speaking of day trip, MWC, right? You're not. I don't know. Are you going there? Did somebody already ask that?
I don't know this year. I didn't go last year just because I was actually training that day. I was giving a class in the States, so I would have had to do like a red eye straight to Barcelona, and that didn't sound like very much fun.
I would love for somebody to just a hint here publicly. If somebody could put me up in Barcelona, I would definitely consider going there. I've never been, and it seems like an interesting thing. And then,
yeah, I'd love to go.
How expensive it is during that week.
Yeah, well, that's why I don't volunteer myself to pay. Also, great drinking opportunities at the end of the day, I'm sure, in Barcelona. Huh? Anyway, thank you again, Michael. Thanks to Range Networks for making this book available free. openbts.org/book.
Yep.
Download it now, or go buy it on Amazon.
And I think it will continue to be free. I think it's just that we have the exclusive download for this month, but I think it will continue to be free for forever. So yeah, it's pretty cool. I'm glad we did it that way.
Yeah, no, that's a great initiative. O'Reilly, we've worked with O'Reilly in the past, by the way. Also, O'Reilly themselves, as a publisher, is pretty good. I haven't heard from them for a while. As soon as I found out the book was going to be free, I stopped writing to the PR person to beg for the copy. So we're cool. All right, with that, we're going to say goodbye. Thanks to everybody who participates, as always. Michael, we'll hope to be hearing some news from you in a little while, whether you're still at Range or you're doing something else, because you're always doing interesting stuff.
That's kind of the goal in having this job, is trying to do interesting stuff. Thank you very much for having me back on. All
right. We'll be back with the mature audiences only in just a moment. Hey, that was the bleeding edge of the IP communications and VoIP community. We're at vuc.me on the web. Thanks to Simwood.com, who can turn you as a developer into a telco. Our host at PBX is provided by onsip.com. The site at vuc.me is on bluehost.com. We use zipdx.com for our wideband, full-featured conference bridge. And our local rate dial-ins are from voxbone.com. Every Friday, 12 noon Eastern Time. See you next week.